All right. So, hey, everybody, my name is James, and this is the first ever collaborative starter kit. We've got a bunch of folks here. Parts one and part two of this starter kit were about where you can find the metadata to kind of figure out how to build your own unsigs. And part two was about then using that code to, in a Python environment, create your own unsigs. And so I just made some that I thought were kind of interesting. And my goal now is to turn these into NFTs. But I mentioned in part one that I didn't want to, this starter kit is not intended to be a comprehensive explainer about NFTs. And so before we get into minting these unsigs, I just want to make two really critical points. One, image storage is a hard problem. And a lot of people have a lot of different opinions about how to best do it, okay? I'm one of those people. I have pretty strong opinions. I know that a lot of tools that present NFTs to the public right now tend to rely on the same handful of infrastructure tools. And there's this idea of recentralism, right? You can have the world's most decentralized blockchain, but if you're using the same handful of tools to access resources on that blockchain, what was the whole point in the first place, right? But storage is hard, right? Decentralized storage is a hard problem because if you want to have as much reliability and resilience as possible, you're generally going to have to sacrifice some level of distribution or decentralization. So a lot of trade-offs, a lot of different possibilities. And so I'm not going to share an opinion on what I'm using for storage tonight. Well, all you need to know is I got these images onto IPFS. Okay, so I have a list. Where did I put that? On a README file somewhere. Creating all 17 of these using the Python script. And now what we're going to do is we're going to put them up on the blockchain. Before we get to that step, however, there's something else I want to do. And that's why I have VS Code open for the moment. And I'm going to switch over to a terminal window. But here we go. This right here is what the metadata file looks like for the Genesis unsig, right? 00000. And this is the only unsig that has all of the source code in it. And anybody who wants to make unsigs can find this metadata in a blockchain explorer, grab the Python code, save it as a Python file, get these dependencies, and start making their own unsigs. And if you have any questions about that part, that's what I covered in parts 1 and 2. So the previous video goes deep into that. And I recommend you take a look if you want to know how to use this on your own. Then each successive unsig from number 1 to the very last one has metadata that looks something like this. There's a link to the image, which is a shortcut, right? That's just a convenience, really, that this is provided. And then there's the parameters that are on this immutable ledger moving forward, right? Anybody who wants to look up the parameters for any of these unsigs is going to be able to do so for as long as the Cardano blockchain is running. Even after, there's a lot of reasons why these image files might get erased or corrupted, right? Or just inaccessible. But if you have access to the Cardano ledger, you can find these properties and you can find the code about how to use them, and you can regenerate your own images. So why would you not put this code here on every single unsig? Why would I make people look this up? And by the way, every one of these unsigs, right, after number 0 references the original one. There's this source TXID. And if you take this transaction ID and you drop it into a blockchain explorer, it'll bring you to the transaction that has this metadata right here on it. So you can reference it. And so the first thing I want to show you now is why you would make a decision like this. Okay, before we get to minting anything, just want to show you this. So here I got a terminal window. I've got a Cardano node running in the background. Okay, and this allows me to use Cardano CLI. So I can do things. I showed this in the last one. I can say Cardano CLI query the tip of mainnet. Today is September 16th, right? So we are in epoch 290. There's been 6.25 million blocks. We entered the Alonso era on Sunday night, and you can see my node is synced, okay? And what I want to do here, yeah, and here's the Genesis metadata file, and here is the every other unsig file right here, okay? And what I want to do here is I just want to calculate the cost of using kind of the smaller file versus the Genesis file on a transaction. So that's what I want to do first. All right, I'm not actually going to mint anything because I'm not actually going to submit these transactions. I just want you to see this to kind of help you think about it a little bit. So this is the step, and Steve and Quasar and I were hanging out a few minutes ago, I was doing a practice run of minting a few of these things just to make sure I understood it. But what we're going to do is just that first step. We're going to say Cardano CLI, transaction, build raw. It doesn't matter too much which transaction we're using. Oh, no, it does, because I can't reuse that one because it doesn't exist anymore. So give me 1 second. One more thing, Cardano CLI, we're going to query the UTXOs available on mainnet at this address. And I just have a wallet address saved as an environment variable right here. So when I do this, I can see a list of UTXOs at this address, right? Anybody got any ideas who's done this before?
Well, I haven't done it before. I'm just wondering, why does it say unexpected end of input expecting digit? What is that?
Right. Option TX. Oh, yes, Steve, you did it. TXN. Sorry. Yeah, I'm not even reading the errors. TXN right there. I'm sure that's it. So let's echo.
I don't know what I did, but I made Kelly proud.
Look, 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 look. There is a missing digit at the end of my TXN. I was supposed to have, so right, whenever you talk about a UTXO, this is great. You need the hash of that UTXO, you need the pound sign, and then you need the index of that UTXO. And I was moving too fast. I forgot to type the number 0 there. Perfect. Thanks, Steve.
You're welcome. I'll be here all week.
Thanks, dude. All right, put a 0 there. Close those quotes. Run the same. Well, yeah, I have a terminal to fix, but that's a different story. Let's do this real quick again. Cardano CLI transaction build raw. Uncut starter kit coming at you. And I hope this doesn't dilute the point I'm trying to make, because it's really important for people to see this part. And what I'm going to do when I publish this is make sure there's some bookmarks that get to the good parts. All right, so in, out, metadata, JSON file, same one. I don't think I need invalid hereafter, so I'm going to skip that at my own peril. And let's still call the out file tx0.draft. Cool. Out, yeah, that was, okay. That time it was the simple error that I just missed having a dash here. It's late in the day. Okay, finally, what we have here, sorry about that, everybody. We did just successfully produce a draft of tx0, and this is the one that has this metadata on it. And that shouldn't have taken that long, but sometimes that's how it goes. All right, I'm going to build another one right now with all the same stuff. Okay. Transaction, build raw. Because, you know, maybe if you're a passive, if you have any passing interest in Cardano, you might have heard headlines about concurrency issues. I'm not going to debate whether they're overblown or not, but basically, I can use the same transaction input here to build two different transactions because I'm not submitting either of them to the blockchain, right? And this would actually be a problem if I tried to submit both, because they would both be referencing the same UTXO input. But if all I want to do is calculate fees, which is what I'm about to do, I can use the same input twice, and I don't have to worry about trying to double spend it. All right. So what I'm showing you right here is not production ready. And if I tried to actually finish building two different transactions with the same input, I hope it's clear that that wouldn't work. All right, but for this one, I want to use the other JSON file, and I called this each unsig.json. Okay. Then we got the metadata. We don't know the fee yet. And this one's going to have an out file called txn, right, for any other. What did I do that time? White space, tx out. Yeah, that needs to be a plus sign, not an equal. Sorry, it's been a long day and I'm making all sorts of errors tonight. And I'm sorry about that. But what I'm going to do here, just grab this, put it on my clipboard, fix it.
You know what, James? For someone who hasn't seen the code in a long time, the repetition is actually helpful.
Good, dude. I appreciate that, man. Yeah, you know, you're always taking risks when you go live, especially at the end of the day, but I appreciate you all hanging with me. All right, one more time. That was supposed to be a plus sign. There was a typo. That's why that one didn't work, but let's do it again. All right, why didn't that work? Invalid argument. Okay.
Kelly wants to give you a hug.
What is going on here? That argument looks good to me. It's an easier problem to fix. There we go. All right. Live and uncut. So here we go. We have a TX draft. We have a TX0 draft, and we have a TXN draft. And I lost in me playing with the syntax here is the fact that this drafted transaction draws on the metadata from the Genesis unsig. And this one draws on the metadata from every other unsig. And all I really want to do right now, the whole reason I was doing this in the first place, is I want to calculate the fee for each of these, okay? See if I can do this without any syntax errors. So once again, Cardano CLI, calculate min fee. Calculate the minimum fee of what? Well, we have this drafted body file. And first I'm going to do tx0.draft. This one is going to have one input and one output. We're not really going to send it. And it's only going to need one witness. And we're going to come back to witnesses in just a minute. And then it's going to use a protocol params file that I downloaded like an hour ago. Protocol.json. Okay, so just real quick, what's going on here? When you calculate the fee of a transaction fees are deterministic on Cardano. It's simple algebra to figure out what they should be, okay? Now, there's a lot of different things that can change that cost. The number of UTXOs you're putting in, the number that you're sending out, the number of people signing it. Also, if you're trying to mint assets, which I'm not actually doing right now, we're going to do that in a minute. But if I was minting assets, this would be a more expensive transaction. The only thing I'm trying to show you right now is all else being equal, what happens based on the size of a metadata file. So remember, this is the big one. Right, of course, I was supposed to write witness count there. All good. All right, let me just put this over here, and this way I'll be able to use it again anyway, so I'm not going to have to type that again a second time. And I apologize for not preloading all these things. This was kind of a last-minute decision to do this. All right. All right, let's try that one more time. Here we go. Okay, so just that original transaction has this cost right here. Right, 272,000 Lovelace, 0.27 ADA or so. And what I'm going to do is I'm going to do the exact same command with an n, with the txn.draft. And look, that's the only thing I'm changing right here, right? This is the draft that has the original. This is the draft that has the successive ones. What's the difference in cost? Well, looks like it's almost 0.8 of an ADA. All right, so let's do a little arithmetic. We've got 272,289 Lovelace, take away 197,489, right? So by doing this, basically, and again, these wouldn't be the real costs. It would be higher than this for each of these because of the minting part, but we're just talking about the difference in the cost based on the length of the metadata. 74,800 Lovelaces, so 0.0748 of an ADA. Why is that not? You know what? I'm just going to use my phone.
That's great. I like that.
That's ridiculous. Whole string of stuff happening. Okay, so 74,800 times the rest of that addition size. We've got, and then we're going to divide that by 1 million, right? 1 million Lovelaces per ADA. So basically, by doing it this way, Alex saved 2,327.6 ADA. What's that at current market value? I don't know how to multiply on the command line, but let's just multiply that by, say, I don't know, $2.50 or so, right? So he saved $5,800 at current market value by doing this one thing, right? And I'm going to make a shorter video illustrating only this point right here. But this is a really, really important thing about the Cardano protocol. It incentivizes ingenuity, right? By linking one transaction to, or every transaction to the one that has the information on it, you can save yourself thousands of dollars, right? By coming up with a solution like that. There's good reason for the architects of this protocol to do that, right? They don't want to bloat the chain. If it was cheap to put metadata on chain, more people would do it. And then SPOs running the chain would need more expensive machines, which would decrease the incentive to be an SPO. And if there was less incentive to be an SPO, then this would be a less secure network, right? So you can see all the way up the chain, this decision to make it expensive and to force those of us building on it to have a little ingenuity as we're building stuff, I think that's a really good design decision. And that's why I think Alex set a really good example by doing it this way. Does that make sense? I wish that point had taken about 3 minutes to make. I don't know how long we've been going for here, but thanks for sticking around. Okay. So that was the first thing. Now let's do the fun part. Let's actually mint a couple of these things right now. And I'm going to show you first this JSON file. Okay. This is metadata. And if you've ever looked at a blockchain explorer, I think a lot of people on this call are here because I put a Zoom link on the Unsig's Discord server. So if you have an Unsig or if you are interested in them, you should definitely learn how to go to Cardano Scan or the Cardano Explorer and find this metadata. And I showed that in parts 1 and 2 of this starter kit. What I'm doing here is I want to mint my own Unsigs. Okay, so because I downloaded that code that we looked at here, and I showed, in the first video in this starter kit, I show how to play with this code and make your own. So go look at that if you need to. But I found a few patterns that I really liked. Okay, and I uploaded them so that they're hosted on IPFS. This right here is a string. The reason it is split up as an array, you can see, right, that there's one string here and the next one here. The reason it's split up is because I had to deal with the string length limit for Cardano metadata. This is 64 characters. That's the limit. So I had to take the last 2 characters in this URL. But if you actually put this URL in a web browser, if you were able to handle IPFS, you'd be able to see this image. Now, when pool.pm sees this URL, it uses an Infura hosting service to reconcile this image, okay? The parameters for this image are here. All right, and I already preloaded this. So my goal right now is to mint 2 Unsigs in a transaction. I have the metadata key 721, which represents NFTs on Cardano. There's nothing special about this number except that a bunch of people got together and agreed to use this number. That's what CIP number 25 is all about. There's a link to that in the documentation for this starter kit. And we looked at that in the previous video, all right? Inside of that object, there's another key right here. This is a minting policy ID. This is a minting policy ID that I just made, and it expires at midnight tonight. So after midnight tonight, I'm never going to be able to use this again. And any Unsigs I'm able to mint by then, that'll be locked. That'll be all. You won't be able to do any more, okay? And you can see that script already on pool.pm, and I'll show you how to do that. I got all the parameters here. We're going to look at all this information, okay? So I'm going to save this because that part's ready to go. And what I have here is I just grabbed all the scripts I need to do this, so you don't have to watch me type all this stuff. We're going to talk through it right now, okay? So this is where I'm going to be copying and pasting from in just a moment. Let me just share back to the terminal so we can watch this happen. Cardano CLI, I'm going to query those UTXOs on the mainnet at the address that I've already saved here. And what I'm looking for is one that doesn't have any NFTs in it yet. So like this one right here, because it's already kind of ridiculous that I'm doing this the hard way, but I'm doing this the hard way on purpose, just to show people what's going on inside of the tools they're using, whether you're using a wallet, whether you're using a site like nftmaker.io, this is what's happening in the background. And I want people to understand the building blocks of these tools, because maybe this will help you have the next great idea. So I like this one right here. This is the transaction I'm going to use, or the UTXO I'm going to use, sorry. I'm going to save that as an environment variable. I'm going to remember to put the index this time so we don't get any weird errors like we did. All right. I've already got my sender. Good. Address, so that's what I need. And now if I just start doing a little copy pasta, this is all going to work, but I promise to slow down and talk through it as we go. So step one, and keep in mind, I've already made a minting policy. I'm not going to cover that in this video because it's already probably too long. But if you need any help with that, there's docs, and I can help you with that some other time. All right. So we're building a raw transaction. This should look pretty similar to what we were doing before. There's just more going on. All right. One transaction going in, one transaction going out back to the sender. But this time it's going to include some new assets. It's going to include one CSKU 914003 and one CSKU 914004. Right. So this is a Cardano starter kit unsig. I made these on September 14th. That's why the 914. And this is the third one I made. And this is the fourth one I made. Each of these is using the exact same policy hash, but has a different name after the dot. Okay. And we're going to look on Pool PM in just a minute after these are made about how that part's expressed. I'm referring to a Mint script file called policy.script, and I can show you that in just a second too. I'm using the metadata file that I just showed you in VS Code. And this transaction will no longer be valid after slot, what's this number, like 40 million. And this happens to correspond to like 12:15 Eastern time tonight, okay? Slots are measured in seconds. So one slot equals 1 second. And so all I did is I queried the blockchain to figure out what slot we were on now. And then I added a couple hours to that. That got us to about midnight tonight. Okay, there's no fee yet because we're about to calculate that. All this is going to do is produce the draft of a transaction. So let's do it. Yes, it worked the first time. That's why you prepare before you start recording. Okay, now that that transaction is drafted, I can calculate the fee. What's up, Steve? Go ahead.
Like if you wanted to make 500 of these, would you have done plus 500? And then the end, whatever the end name would be?
So if I did, good question. If I did a plus 500 right here where this one is, it would mint 500 copies of CSKU 914003. If I wanted to make 500 unique NFTs, I would have to say one policy ID plus name, plus one policy ID plus different name, plus one, plus the next one. And they would each have to have unique names.
Okay.
Okay. Same policy ID, different name each time.
Okay. So it's hard to do a batch and get everything to be different without doing that. That seems kind of repetitive work, right?
Okay. It's damn right impossible to do by hand unless you want to drive yourself crazy, but this is where scripts come in. You would automate this, right? Okay. And this is a great rule, right? Anytime you see yourself repeating yourself, that's when you can say, right? I could probably automate this. I could probably script this, right? Yeah. And I'm going to put this process file from which I am copying and pasting right now. You'll be able to access this and look at these commands. And this is what's going on. All these commands are being used under the hood in every tool we use, right? It's just that usually they're being abstracted away and hidden from you. And they're being run multiple times really quickly because that's what computers can be programmed to do. I'm just showing you at a very low level what's happening underneath that. So we got one transaction going in, one coming out, right? All this is, right? It's coming from one wallet, it's going back into the same wallet, okay? But there's two witnesses. And the reason there's two witnesses is that the wallet holder, me, right, with the private keys for this sender address that we're using up here, has to sign this transaction to say okay to the funds. But then also the key holder of this policy script, which in this case also happens to be me on this device, right? I made this policy a couple hours ago. This also needs to be signed by a signing key in exactly the same way, right? That's why we have two witnesses. And this is going to give us a transaction cost. And you see how it's a little bit higher than what I showed you earlier, because this time we're minting, right? It's not just about including the metadata. It's about the minting cost too. So these are, right? It's just equations though, right? You have this much metadata, you're minting this many things. That's all built into the protocol to deterministically calculate this cost. Okay. All right. So the fee now is equal to 235,285. And the change is going to be equal to, I should double check this real quick. I just want to make sure. Query the UTXOs on mainnet at address of sender. And I used echo TX in.
Hey, Steve, so that price was higher too because it was minting two, right? Two unsigs instead of one.
Right.
That's why it was also higher in cost. That's what I was going to ask.
Yeah. So I'm really curious about this process too.
All right. Hey, somebody had a question? I saw a hand go up.
Oh no. The reason why the Lovelace was a little bit more expensive was because you're minting two unsigs, right? I mean, that's calculating for two mintings.
That's exactly right. Right.
Yeah. Okay.
Right. If I was minting one at a time, this would be lower. But I think about it, right? So you have, if I think of this like a linear equation, right? The starting value is the 0.17 eta, right? Mm-hmm. And then you're adding on top of that cost for each minted asset. So you definitely save money by minting multiple at the same time.
Okay.
Right? Because you're not adding that basic cost. So what I did is I already got the fee, which is right there. And I just need now to calculate the change, right? Because we have to balance our transactions. I'm starting with 3 million Lovelace. I'm paying a fee of 0.235 eta, right? And I need to return exactly the number of Lovelaces back to the wallet. Otherwise, this transaction will fail, right? Lovelaces have to be conserved. Every last one of them, even, right? They're 1/1,000,000th of an eta, but every one of them counts. So the change is going to be equal to 3 million, take away the fee that I just calculated. And now if I echo change, I can see that right there, okay? So the wallet's going to get back 2.76 eta and a couple of brand new NFTs. So next step. Now I'm going to draft the real transaction. It's going to look similar to what I put up a moment ago. Okay. I'm still saying transaction build raw. I'm putting the same transaction in, but this time, instead of sending 0 Lovelaces to the sender, I'm sending the change back, that number that I just calculated. I'm still making one of these, number 3, and another one, number 4. I'm minting them, right? So the transaction out says, send these things to this place. And then mint says, hey, here's what you're making in the first place. The script, which I said I was going to show you, I'll get back to that in just a second. The metadata, same as before. Expiration date is a little bit after midnight tonight. I won't be able to use this policy ID ever again after midnight tonight. The fee that I just calculated, and we save that as a raw transaction, okay? And anytime nothing happens on the command line, you're happy. That means it worked. And if I say list files here, I can see TX raw right there. All right, the last 2 steps are actually really easy. All I have to do is sign now. This is the step that if you're talking about real and like substantial amounts of money, you shouldn't do this online. When people talk about air-gapped machines, what they mean is that they're keeping their S key, their sender or signing key files on a different machine. And what you can do is you can actually put like a raw transaction on portable storage, bring it over to a machine that's never been on the internet, where you have your keys stored. You can sign it. You get a signed transaction. Then you bring that signed transaction back to your networked machine, and you can upload it to the chain. Okay, so I sign it. That works. Now I have a signed transaction. And then finally, I can submit it to the chain. I hope this works, because if not, we're going to have to do another long bout of troubleshooting, but let's see. It worked. All right. So if you go to Pool PM right now and you click that NFT button, these two NFTs are going to show up there right after the next block is minted. Let's see. All right. So basically what my computer says is, okay, the transaction is submitted. Now I have my node still running right here in the background, right?
Well, I think one of your NFTs is just going to be green.
That's exactly right. You're right. You see those? Yeah.
Oh,
exactly.
yeah, it's just going to be a green square.
But what I did is I actually messed around. You'll see this in just a sec. I was messing around with attributes that Alex didn't use in the initial run, right?
Oh, okay.
And you'll be able to see those. Where are these things? This is actually taking longer than the last batch did. Here they are. Okay, they scrolled down half a minute ago. Numbers 3 and 4 are up there now. You can see the green one.
Yeah, I see it.
Okay. And you see that one, I used multipliers as high as 40, right? Just to see what would happen, and all normals. And then the other one is right next to it. That one is less busy, but I thought those colors were beautiful, so I chose to make it. Okay.
Nice.
So who's got questions? I'm sure people got some. And actually, by the way, if you are looking at one of these on Pool PM right now, underneath the name of the asset, it says policy, and you can click on that link and you can actually see what my policy script looks like. Okay. And you can see that this policy script, should I share my screen for that part?
Yeah. Yeah. Because I'm really curious what keeps people from ripping you off, right? Just going to another community and saying, look what I invented. And they don't know what Alex has done or what you've done with the script.
All right. So I'm going to go back. I'm just going to do this in VS Code again, because it's easier to navigate through all these things. Okay. So let's talk about the policy script first.
I pasted it in the chat. If you guys
want thanks, dude. And yeah, this is the file. This is on my computer. This is the same thing that you'll see on pool.pm is this text right here. Now, to be clear, the only reason you're seeing this on pool.pm is that I cut and pasted it there. Okay. This doesn't show up automatically, but once I added it there, now it says this policy is registered. So it gives a little more bona fides. And you can see this policy will be locked 2021, September 17th at 4:14 UTC, right? So a little after midnight my time. It'll be impossible to make any more of these things. Okay. Now, what's keeping people from ripping me off? Two things. Okay. Actually, three things, but we'll get to the third one last. This script says type all right here. What that means is that everything in this scripts array right here has to be true. All of these things have to be true in order to mint with this policy ID. So what are the two things you need? You need the signing key that goes with this hash. I have that because I just made it a couple hours ago. And this has to be executed before this slot, which, as I've said, is a little after midnight my time tonight. Okay. Now, anybody who wants to can put a picture on an NFT. Anybody who wants to can call their NFT an unsig or anything they want, right? But nobody who doesn't satisfy both of these requirements. Thanks, Nico. Thanks for hanging out, man. Nobody who can't handle both of these requirements can make an NFT with this key right here, okay, with this policy ID right here. That's the thing. And so, like I said, the third thing, right? So you need a signature that goes with the policy ID. You need to be time bound, right? If you choose to put that in your policy script, but you also have to rely on end users being smart enough to understand this, right? And this is the hardest thing about blockchain is that most people, and it's not just smartness, right? It's the effort you put in, your ability to pay attention. There's lots of people who don't have time to learn how to use blockchain, right? How many friends does everybody on this call have who say, wait a minute, if I lose my mnemonics, what happens to my money? What? You want me? I would rather use a bank. And you know what? People who say that, I can't argue with them, right? I mean, I could get on my high horse and talk sovereignty. I could talk about how evil a bank is, but guess what? It's pretty damn convenient to put your money in a bank. And at least you don't have to worry about yourself losing your keys, right? now I'm playing devil's advocate with myself here. I disagree with a lot of the words I'm saying right now, but I'm just saying, right? This is the thing about blockchain. It requires another level of understanding for people who use it, right? Because anybody in the world could go out and ape what I just did there, but with a different policy ID. And if nobody notices that it's a different policy ID, right? How many of you have ever searched for your favorite NFT on cnft.io? How many copycats do you see there?
Right, and then that's why you reach out to the owner with the policy ID, and then he uses, I think, like 3 different ways to identify that you actually own that policy ID based on social and, oh, he has a website, everything you do to really validate any project, and then he'll give you that magical, checkbox. But still, what, over the course of the last month, how many hundreds of different projects have been developed for Cardano? I'm sure 1 or 2 have slipped through the gap there to be verified when it's not really a valid project. I'm sure we're going to hit critical mass with unsigs after smart contracts come on board in the quantity and quality that we're expecting. And there's going to be some clones. You're definitely going to see some unsig clones. And I
just minted some.
Well, you just did, but I mean, yours, you didn't specifically use the same parameters that Alex did to generate that specific unsig. Someone could do that,
right?
Yet it's almost like, okay, I bought a Matisse. I know it's a Matisse because I can carbon date the ink in the painting the same way that you can go into the code and verify that the policy ID of this unsig is different than the policy ID of that unsig, even though they're identical. One is a forgery.
That's right. And and you're right, you can go talk to people, and that's really a great way to interact with the world, and we should all be doing that. But you can also just go to like Cardano Scan, and you see, if you're on Pool PM right now, you can see, right, that policy ID under what I just minted there. And then you can go to a blockchain explorer, you can search for that, and you can see the total supply, right? You can see all the ones that have been minted, and you should be able to find yours, right? All these have a fingerprint. And if your fingerprint is not in this list, then you don't have a real one. Sorry, I'm looking at a different screen right now, but you guys know what I'm talking about.
No, I get it. If you put in Alex's policy, you get 31,119.
Exactly. So, yeah. All right. Hey.
Well, hey, I gotta jump, but it's really informative. I'm gonna go backwards now and watch, like Star Wars, go backwards in time and watch the other 3. But yeah, it was great. I'm gonna dive into this and start making some of my own.
Thanks, man. Thanks. And yeah, thanks for hanging out. We'll talk more. We're gonna do another one of these tomorrow about the lobster challenge, if you heard about that. So like, now that we've talked about minting and metadata, now we can move on to saying, all right, what else can transactions do?
Cool.
Be in touch. Cheers.